So students, in the continuation of metal forming process, now we're going to drawing process. In the drawing process, we can make tubes, making deeping drawings to dumblers and plates which are used in your home, and we can make a wire also. Let us get inside and we will check how we can make this is useful one. Okay, so this is the overlay of the drawing process. In any drawing process, particularly for tube drawing, we should have three things. One is mantle and the material and the die. As you can see, die is stationary, mantle is also stationary. Only the material which is placed over here will be moved by the applied force or the pulling force. So that material will move from this place to this place, and depending upon the mandrel shape, we will have hollow tube. Okay, and this is a cross-section view of the tube drawing process, and particularly you may easily understand how it looks like. Okay, so as I told, we have die and we have mantle, and work is passing through from this end to this end, and we are getting one hollow tube. So this is the way how we can make hollow tubes. Moreover, we can go for seamless, but it's very difficult. So because we are taking certain quantity of material, then we are pushing through one die through mantle, so that it will not make a seamless. But if you want it, we can make it in another way. Okay, and if you are not going for hollow, means can you go for solid? Yes, as you can see this image, we can make a solid tubes from the metal form drawing process. As you can see, this is the angle of approach and entry zone, which is very important. In while solving the problem, we will see how we can solve the problem by using this one. We are going to calculate what is the friction or how much power we need, and what will be the approach angle and their effect. And outside we have bake relief angles. Okay. Now another way to making the tubes is extrusion process, and previous topic we have covered how extrusion process is working. As you see, it's a forward extrusion where you are giving force this direction. Work is also going to come out from this direction. So we call this is a forward extrusion. This also we can make tubes. Okay, so what about the wire drawing and other things? Yes, if you have certain amount of material, you have to pass it through some die, so that we will get continuously will get some reduction. Finally, the required dimension will be released or will be achieved. Okay, within one attempt it is very difficult to achieve this much of thickness. See, input is this much and output is this much thickness only. So it is necessary to apply these step reductions to get a required thickness. Don't worry, I will tell how the reduction is happening and why we are using 3 instead of 4. That we will discuss when we going for numerical problems. Okay, now this is how we are taking. There is an initial content is available, first reduction, second reduction, third reduction. There is a pulleys which is going to support, and here the coil where we are going to own this material. Okay, so here you can see that initially with coir wiring is available. It's a first reduction, drawing dies are available, then capstan drum which is going to support the wires, so that it will pass through the another die, and finally it will reach the receiving coil where it's going to be wound finally. So very nice. And this is then another diagram how it looks like. Let me check. It's a wire wounding coil. First is going to the initial supporting place, then it's going to the box containing lubricant. You may ask why? Because here the wire is very thin and small. If any friction is happened while passing through the die, so what will happen? Due to the heat generation, this thin wire, and we are giving apply some force also, so there is a chance of breakage. So that we are going to use lubricants while passing through the die. The lubricant will carry away the extra heat, and finally with a nice dimension or accurate dimension, we will get the coils. It will be wound over the drum. Okay, and it's a deep drawing process. There is some amount of calculation will be a drawing ratio. We going to find out what is the blank diameter and the punch diameter, those things. Don't worry, we will see these things when we are going for numerical problems. Nothing to worry. This deep drawing process only very much helpful for making the pans, cooking containers, sinks, automobile parts, etc. And very interesting. Now these are all the parts. First we have one die. Green color is the die, and blue color is the blank holder, and ash color is the punch. and this light ash color is the workpiece. Initially the workpiece will not be in this shape. We are going to apply the force. After that only it's going to change its dimension, and the next slide we will see how it's going to happen. But before that, you can see the red color arrows holding force and drawing force, two forces we are going to apply. Okay, you can see here we have something different. Oh, that's also. So initially we have taking the plates and we are placing over here. When you are applying the drawing force, it will come down. If there is no holding force, the total sheet will come down easily without making any deformation. So for that only we are going to make the blank holding forces or blank holding forces over here. So when the process is over, the completed shape will be come down. In actual cases, it will not come like this. There is some errors are available. We will see how the errors. So making the initial blank, this is how we are making. It's a big sheet. We have to find out how much blank size is needed. After that we have to punch it properly, and this is the die. It actually is like a tapered portion, so that punch is placed, that portion which is blank after the punch will easily come down without any struggling inside the bath. So that easy removal we are making, and there is a shape, punch shape will be very sharp. Okay, now and this is how it looks like. Initially it's a blank, one attempt, second attempt, third, fourth, fifth, and finally the final product will come. Here also the plate, the bucket, mug or whatever, can maybe this start from this normal flat blank, and slowly it was deformed and its dimension was somewhat changed. And you can see this is how the product is going to happen. You have to see this diagram from right to left. This is the starting. Initial blank is coming and initial shape is making, another shape attempt and another deformation attempt, and we are going to get the clear cut one, and we are going for finally final product. You may ask one question, sir, why don't we make it in a single attempt? Yes, if you are making the single attempt, first we need maximum force. Second, we can assure that we will get a clear cut output. There's two reasons why we are making this thing. Okay, and these are all some defects which is occurred while dealing with the thin sheets, particularly for the drawing process, deep drawing process. Flange wearing, wrinklings, that is nothing but the top side you can see it is not in the correct shape. Wearing is wall wrinklings is nothing but here you can see the dimension is not that much good as like the final product. If you want, yeah, as like not like this final product, there is some waviness over here, that's it. So fractured rim and the bottoms, and you can see this is the fractured thing. It is not attached like this, it was somewhat different, and due to the improper design of the punch, die, etc., and the material selection also. So corner fracture is in the corner going to be fracture, and directional earring is nothing but you can see how the waviness is taking place, and missed ring is nothing but the one side is small and another is big. Please go through the book and read it clearly. Okay, this will be your one of the assignment from this metal forming, so you should go through the books and you have to study this thing very well. And you see, due to small holding force, yes, if we are not properly giving the holding force, then this wrinkling will be taking place. Punch force is very small. We should take the corresponding punch force, then only we will get. And you can see if the high holding force is available, so it is not allowing the material to yield it maximum, so crack is appeared over here. Anisotropy material behavior means each material have their own rolling direction and their behavior. So if the rolling direction is 90 degree, they have some different behavior. 45 degree means they have another behavior. 0 degree means they have another behavior. We should identify which one is the best and safer for the punching process, and we should select that orientation only. Professor Gundal Manji, who is well expert in the metal forming, if you want, you can ask him. He will give more details. Yeah, no problem. And here you can see friction and lack of lubrication at the seat bench. And that also not a problem. And these are all the products which may be taken from the deep drawing process. It will be very interesting for you. I have one small video clip, and go to the video clip. You will get an extra details. This is a single machine which is going to collect all the data. One machine, it can do all the process. Initial shearing is coming, so it making the blank. When the blank was made and series of drawing process is going to applied, you can see one by one his reduction is taking place, is changing its dimension from one smaller to bigger. Okay, then it's moving to another end. The final product we will get, that is the punching the die, how it's making, then it's taking back and slowly it's moving. Finally we have our final product. Now finishing process is going on. If you need, you can do the finishing process, otherwise you can take that finisher product, that's not a problem. Now this is how the mass production is going for a certain design, if you have no other changes. So thanks student, thanks for watching. Subscribe the channel so that you can get the update. Kindly go through that all video clips, so that only you will get the complete package for manufacturing process. Thank you.